Now, this dichloromethane will again react with this chlorine. I mean, in this reaction, the product, each and every product which is formed becomes the reactant over here. So the next reaction this will become the reactant over here, and this chlorine will again substitute a hydrogen. This will remove this hydrogen and come over here, and this hydrogen will go with this chlorine, forming again HCl. So this becomes CHCl3 plus HCl. Now this compound will be called trichloromethane, and this compound is basically known as chloroform. You might have heard about chloroform. That means if you smell strong chloroform, then you lose your consciousness, and it is used in all these serials and films to make the villain comes and uses this chloroform to make them lose consciousness and all. So this trichloromethane is formed, and still there is one hydrogen to be substituted. So again this becomes the reactant. And what this will form? This chlorine will replace this hydrogen again, and this HCl will come out. So basically it forms CCl4 plus HCl. This CCl4, which should be called tetrachloromethane. For four functional groups, we have tetra. We have di, tri, and then tetra. And this is commonly called carbon tetrachloride. Remember, we drew the structure, electron dot structure of carbon tetrachloride. This is that carbon tetrachloride here. So basically, this substitution reaction is a chain of reactions where in each reaction the product which is formed becomes the reactant of the second reaction. So, and okay, one important thing is that again in this, if you have chlorine but it's only 1 mole, then what would be X? So we see that chlorine is only 1 mole. So it cannot substitute hydrogen over and over again, because in the first substitution this 1 mole would be consumed. So the product will be only CH3Cl plus HCl. And if you say that chlorine is in excess and the products are X, Y, Z, okay, not X, Y, Z, we'll have A, B, C, D, E. Find all of A, B, C, D, E. So what happens is that you have this first reaction producing CH3Cl plus HCl, but because of probability reasons, this whole of CH3Cl does not form CH2Cl2. I mean, this whole of CH3Cl will not react. Some will remain. So some of CH3Cl remains and then CH2Cl2 is formed, obviously with HCl. Again, when this CH2Cl2 reacts, this whole of this will not react. Some will remain, some will react. So the one which reacts, which will be CHCl3, which is chloroform, and again HCl. Again, some will remain, some will react to form CCl4 and HCl. So basically, we have little bit of this. So if you have all the 5, if you have to name all the 5 products, then it will be CH3Cl, CH2Cl2, CHCl3, CCl4, and don't forget HCl. But if you are given that only 2 products are formed, A and B, then you have to assume that all of the CH3Cl will react to give CH2Cl2, all of the CH2Cl2 will react to give CHCl3, all of the CHCl3 will react to give CCl4. So in the end, what you will be left with is just CCl4 and HCl, because the HCl is just adding up in each reaction. So A is CCl4, B is HCl. You also have, substitution reactions of ethane. This will give Cl, and then again it will be subsequently adding again and again, but we'll confine our substitution reaction to methane, and most probably methane will only be asked.